Hi, this is Mike Hendrickson from Velocity, New York. I'm here with Michal. How you doing?
Hey, I'm doing well, thank you.
You're with Intel.
I am.
And Intel at Velocity, what is the story here? I'm very curious.
Right? Yeah, so the connection is that we're introducing a new solution that combines FPGAs and Xeon processors. Xeon processors are well known, well established in clouds and data centers, and we think that this FPGA technology can help accelerate a lot of workloads, a lot of applications that are running in the cloud, make that acceleration a lot more power efficient than it's been today.
So are these FPGAs in a way kind of pluggable? And like a DevOps guy is going to bring in a whole array of something and plug it in?
Just bring in a cart, right?
Yeah.
So there's actually a couple of different form factors we're working on. So there's one form factor that has the processor and the FPGA together in one package, goes into the same socket as the Xeon processor. And then the other form factor we're working on is exactly that kind of pluggable form factor. It's on a PCIe card. You can put in a couple of those into your server, and away you go.
And so why would a DevOps want to do that? I mean, what's the threshold that they're going to get to where they're going to say, hey, we need to start looking at a new technology like FPGAs to manage our business?
Yeah, so what we've noticed is that a lot of data centers that are being put together today are being put together for the next few years, right? You buy a piece of real estate, you put the building in there, and you've got a certain amount of capacity, and you hope it's going to work for you, right? For the next 5 years, 7 years, whatever your lease contract is, right? Now, the other thing we're noticing is that there's ever more data that's coming into the data center from IoT sensors or just kind of out there from the internet, right? So we're seeing gigabytes and terabytes and so on of more data coming through. And that is all putting a strain on the servers that are in the cloud, right? You've got to process a lot more. You've got to do that quickly. You've got to do it in real time. And we think that FPGAs could serve well to try and fill that gap there.
So this is all about expansion and growth for the future and being able to figure out what our demand's going to be. Mm-hmm. Are you guys building AI into that as well, so you can help, in a way, size it going forward? Or?
Well, we're not quite there, but what we are doing is we're making AI frameworks and workloads available for this platform that we're putting together and bringing to market. So it is possible to accelerate certain inference algorithms, image recognition, for example, with FPGAs, do that very quickly, do that at scale, do that in a power-efficient manner. So that's where the focus is at the moment.
Okay, and so FPGAs, if we were to look back at their history, how long have they been around? Because it seems like a new term.
Yeah, so it's definitely a new term for the data center. I think there's only been a few customers who have really used this in earnest at scale. FPGAs themselves have been around since, I guess, about the 1980s, right? So just over 30 years.
Initially, like AI.
Kind of like AI, yeah. They were initially used to prototype new chips, new ASICs, right? Then they started being integrated into different kinds of specialized equipment, medical equipment, radar installations, right? Wherever you had a lot of data that you needed to process very quickly in a very power-efficient manner. And we think there's an opportunity in the data center. We certainly have some customers that recognize that too. And so we want to bring that to the masses. We want to have a robust framework. We want to have an ecosystem of partners that makes FPGAs a lot more easily consumable from virtual machines, from containers.
And if you were to speak with a CIO right now and say, what is the biggest benefit that he or she can get from moving to FPGAs? What is it they're going to get?
Yeah, so I think they're going to get a couple things. The first is that they're going to get better TCO potentially, right? And the way that calculation comes about is that they'll be able to get more utility out of the server that they've invested in. So they'll pay a little bit more to get that FPGA in there, but they're going to get maybe an order of magnitude more performance, right? So for the same electrical bill, for the same cooling capacity, for the same real estate that they've already priced in, they're able to get much more performance. So their cost of serving an individual user falls. Now, there's another potential benefit, which is that they might have a better SLA, a better service level agreement, because they'll have lower latency, they'll have better predictability on their response times. That's important for folks. So I would say that those are really the key ones.
And there's no complexity added because of them? Will there be, like, if, let's say, just a server goes down.
Yeah.
Heaven forbid, in December, a server goes down.
Sure, yeah.
Is it going to be more difficult to untangle that with an FPGA in the mix?
Yeah, so we're trying to invest in a robust framework that makes it as easy as possible to use those FPGAs, right? And we're trying to integrate into standard orchestration frameworks for virtual machines and containers that understand how to do failover in the case of a catastrophic event like that, right? So we're trying to plug into those paradigms and make the FPGA an equal class citizen so that we can do that, have that line of sight that we have right now with disks and with processors and with memory, right? And be able to do some provisioning as we need to.
Okay, Michal, if you and I sat down 12 months from now and we sit in this room next year and have this conversation and I ask you, what has changed over the last year?
Yeah.
What do you hope to say from an Intel perspective, what has changed?
Well, I hope people are going to see more manifestations of FPGAs and FPGA algorithms in the data center. We're just starting off, but we think that there's a lot of potential for different workloads. We're really bullish and optimistic about the partners that we're working with, and we think that they're going to help us really complete the solution. There's a lot of value add that they're providing to make the FPGA a lot more palatable, right, for our end customers who typically operate just in the software layers and software programming languages. So we want to really complete the picture. We want to complete the stack, right? We want to have a much broader ecosystem of partners, and we're well underway.
Excellent, Michal. We look forward to that conversation.
Thank you.
Thank you.
Thanks so much.